Hey, Blue Teamers, we're ready to continue our discussion of fossils today and fossil types in particular. And as you can see, Rosie's decided to sit this one out. She's just going to lay there and casually demonstrate those different types of fossils we're going to talk about. So, the first one you see here is a really common type, and that is called a mold. And it's an empty space left in the rock where something was buried. As we said, that's what really has to occur. The organism has to be buried in some type of sediment, be it silt, mud, clay, sand, whatever that may be. And slowly it will decay away over time. And once it all decays away, usually after the sediments has changed to rock, and as you should know, that would be sedimentary rock, which is the rock type you're going to find most fossils in. The empty space is left. And these are brachiopods. These are shelled organisms that lived hundreds of millions of years ago and were very, very abundant at that time. So that is a mold. So on your Google slide that you should have out for letter B, molds, you should fill in the words empty space. So there it is. For 2, number B, molds are an empty space left in the rock after the organism has decayed away. And there's our example of the brachiopods. Now, what can happen is, over time, little minerals from the surrounding rock seep into that mold and fill it in and make a three-dimensional replica of it. And this is what we call a cast. Okay, so it's kind of like a Jello mold or a cookie cutter. That's just the shape of the organism. That would be like the mold. And if you filled it with Jello or cookie dough, that's the cast. So I'm going to show you a cast here of a trilobite. Okay, trilobites were very, very abundant hundreds of millions of years ago. They had a hard exoskeleton, kind of like some insects you may be familiar with. They weren't insects, but they had this hard exoskeleton. What you hear crunch on a beetle or something if it gets stepped on, that's the exoskeleton. Or the part of the crab leg you break and snap, that's the exoskeleton. These were one of the first organisms with eyes. And let's see if I can kind of, it's hard to see, but get it in focus, you can see there's kind of like eyes there. Trilobites came in many sizes. That's just a smaller one, but they can be as big as Rosie's head, or even a little bigger than that. There were several different species. They lived in the shallow seas hundreds of millions of years ago and eventually became extinct. But the trilobite is a really common fossil, not as quite as common as brachiopods, but you can find those wherever shallow seas once existed. And that's a good example there of a cast, which is when a mold is filled with minerals from the surrounding rock and makes like a 3D model of it. So after cast, which was letter C on your Google slides, you see letter D is carbon film. And this is a fern frond. They don't call them leaves, but fronds. And those little dark circles you see, those are the spores. See, ferns don't produce seeds. They produce spores. If you ever have a fern as a house plant or have one in your yard somewhere, look underneath the frond and you'll see the spores on those. So what happens with carbon film is the organism gets buried again in sediments. But what happens now is as the sediments build up, a lot of the material that made up that organism gets kind of released away and leaves behind only carbon. So it's usually either dark brown or black in color, and it's just the carbon residue that's left behind by that organism. So this is a good example of carbon film fossil. And a lot of the things that aren't hard parts, like fern fronds or leaves on other plants, or a feather that don't easily fossilized and are very uncommon, you can get carbon film fossils. So there are softer parts of an organism that can fossilize, and some of those will be carbon film fossils like you see here. So that's letter D of our fossil types. Okay, so we're down to the last two types of fossils, and Rosie actually woke up for this one. She finds it that interesting. This type of fossil is going to be what's called original or actual remains. So everything we have talked about up to this point has been a fossil where the organism, the real parts of it decomposed, leaving just a shape in rock, for example, or sediments filled that in, forming a cast, or with petrified remains, the original parts were slowly replaced by minerals, but there weren't any real parts of the organism. Well, under the right conditions, that can occur. Even in rock, but generally that would, for the most part, be organisms that are not millions of years old, but tens of thousands of years old, for example. So there are certain materials that are really good at preserving organisms without letting them decompose, and that's what you're going to fill in for letter E, where it says actual remains when parts or whole organisms are preserved in. And what you see right here is one of those. This is amber or hardened tree sap. The other substances would be ice or tar. So for number 2, letter E, you should fill in on your Google slide amber, ice, or tar. Okay, and what you see here is some real tree, hardened tree sap, amber. If you've ever been real close to a coniferous tree or a pine tree, for example, and you maybe got some of that sap on you, know how sticky it is. So insects and other small organisms or parts of a leaf or a seed or something get caught in that sap, and then it'll harden and become what we call amber. The other sample here, and it's really kind of hard to see, just kind of a dark spot. Those are actual small insects that are in some amber. Come back next year, I'll give you a better look at that. In the movie Jurassic Park, when they were trying to recreate the dinosaurs, that's what they used was amber, and were able to extract the DNA from the blood of those dinosaurs that was trapped in the mosquito-like organisms and so on. And as I said, things like ice or tar also are good preservers. The La Brea tar pits in Los Angeles, if you ever get out that way. So this is not something we come upon so much today, but the petroleum-like or thick tar material would come to the surface. Water would lay on top of that. The animals would go in to get a drink of water, get trapped in the tar, and then Rosie just got really excited about that. And then something would see that animal trapped in the tar, go in to try to possibly, have a meal, easy meal, get trapped in the tar as well, and eventually get buried in that tar and actually really preserve them, kept them from being decomposed. Ice obviously can do the same thing. Every once in a while, some ice will melt away, and they'll see some hair up in the Arctic regions, and there'll be a mammoth or mastodon, and everything's there: the organs, the eyes, the tusks, the hair, that's why there's still the possibility they could maybe bring those back if they can get the DNA from those and fill the rest in with from elephants possibly. So these are really good preservers, and it can even happen in rock with more recent organisms, but this is the real deal. And if you look at the Google slides, I have some pictures of some mammoth parts, a saber-toothed cat, or Smilodon, and then on the next page some things trapped in amber. All right, so that should be for number 2E, amber, ice, or tar. So we're down to our last of the fossil types, and this is what we call trace fossils, and it's another unique type of fossil in that it doesn't show any part of an organism. You're not going to see a shell, any bones, you're not going to see feathers, you're not going to see leaves, fern fronds, any real part of the organism. But it does show evidence of life. And as you remember from the definition of a fossil, that's what's important. Does it show evidence of life? So in the definition for letter F on the slide, it says trace fossils show that an organism existed, and then you're to fill in the word without. Okay, so you should put the word without for 2F. Without showing any part of the organism. So this can be tracks or footprints, a burrow. You see the word coprolites, that's what you see here, and we'll talk a little more about that. So it shows something lived. A nest, for example, and we have fossilized dinosaur nests complete with eggs. So it shows that something dug a burrow, created a nest, left its footprints, which is really amazing that if you think about when you walk through mud, for example, what are the odds that that would remain there long enough, get covered up, and become fossilized? And you'll see some pictures on the other slides that come after this. And on those ones you see going like straight up a cliffside, that does not mean like something like a dinosaur walks straight up a vertical hillside. It just means that rock's been uplifted. So you should have filled in the word without, and what you see here is what we call coprolite. And it is what it looks like. And I know Rosie is not in the picture, and she did not leave this behind as well. But a coprolite is fossilized, for lack of a better word, poop, fecal matter. And we can tell a lot from this. See, trace fossils tell us a lot. Coprolites can tell us how big they were, what they were eating, and things like that. So we get a lot of information from these types of fossils. Footprints and so on tell us if they traveled in herds. Did they care for their young? Even how fast they moved. So we can get a lot of information from these. And that's why if you were with me at the museum, I talked about how they lifted all the tails off of the museum floor of those dinosaurs. Because when they did find tracks, they never found a tail mark. So they knew they kept their tails up in the air. They did not drag on the ground. So this, if we were at school, you'd get a chance to actually hold this. It's rock, so it's not that disgusting. It's been replaced by minerals. Again, what's the odds of that? But it happens, and we have these coprolites. And you can look at the other slides to the end of the Google slides that are there for you to look at. All right, that's fossil types, guys. There's going to be a little activity coming up next week, and then we'll move on to some other Earth history. All right, guys, stay safe, and I hope everybody's doing well.